Okay, then I can introduce a bit about myself as well.
Yeah, we are ready. You can introduce yourself and start presenting.
Okay, great. Okay, can you see my screen?
Yes, we see
Yeah,
your screen.
great. Okay, so today we're going to talk about UTXOs and nullifiers. It's a very exciting topic. Just a little bit of background. So for me, I'm Shinki Web3, my Discord name, or Chunhui is my real name. Yeah, so I think I was in the ZK Ignite cohort 2. So it's a very exciting time. So I propose, building a privacy coin directly on Mina. So it was very strongly inspired by Zcash designs. So in the middle of the ZK Ignite, after discussion with a couple of people, I pivoted the design to use UTXO on the privacy side, of the coins, right? And then done a couple of research, into the research papers, into nullifiers, into the code itself. So today I'm kind of sharing a little bit, of the journey, what I went through, a little bit on how to use UTXOs, how it's used in privacy coins, and maybe some ideas of how you can use it. Yeah. Yeah, I mean, for me, kind of developer for quite a long time. And I think Zcash really sparked my, ZK journey, right? The time when it came out, it was shocking. I think it was shocking for many people. It was shocking for the whole crypto community. Wow, that something like this was possible because I was in the academic, doing security. So I was looking into crypto, for many years. I haven't touched it for a long time. Crypto as in cryptography, right? Not cryptocurrencies. But I think for the as far as I can remember, for the longest time, this fully homomorphic encryption was like the holy trail that I think for a good 20, maybe 30 years, then no researcher was able to kind of have a good breakthrough in that area. There were algorithms, there was stuff that was proposed, but nothing really practical and nothing that can be production ready until Zcash came, right? So I think that really changed a lot of things. So I studied a lot about the Zcash design. So that inspired me. And what's exciting about Mina is that now we can do something like Zcash, but with smart contracts. So that's what kind of inspired me, to do this project. So yeah, so I guess I'll dive a little bit into some of the background. So in general, about UTXOs first, right? Why do we use UTXOs? So if we try to kind of have some privacy preserving data structures, I think everyone here, I'm sure you're kind of very familiar with Merkle trees. I think that is very powerful for hiding the content, right, in the leaf nodes with some hashing mechanism. So it's quite easy to fully decentralize the system. But in order for your Merkle tree or the application that uses Merkle tree to truly be fully decentralized, right? Even though the hash does allow you to protect the actual contents of the leaf nodes, or the pre-image, or what we call it. However, the Merkle tree does need to be fully reconstructible, using public data, right? And this usually comes in the form of emitted events, which means that both the leaf hash itself and the leaf index, needs to be public, right? So the leaf hash is fine, but as I was going through ideation and thinking about how to build, the coins, the leaf index became a problem, right? So I'll kind of explain what the problem is. So the coin design that I was proposing, right, has a public, balance, a tree that contains all the balance, and also a private tree that contains all the balance. My initial designs was such that, I mean, public side, is very simple. It's public. You have the key, you have a balance, you have a Merkle tree here. It's very straightforward. On the privacy side, I was proposing having a nouns, a random nouns that's chosen by the user, and this will effectively anonymize the balance, right? So the balance plus the nonce, right? To get the public key will be hashed and stored in the root. So in this way, no one can deduce the balance unless they also know the nonce at the same time, right? And all operations of updating the balance will involve the private information of the nonce. So this can maintain and make sure that you always have the same total sum in the tree, right? So there can be no double spending of sorts, regardless of the nonce value. But the problem is that the index position of this tree node will always be fixed. So even though I may not know the actual balance at that tree location, for example, this location 10, right? But someone's balance at location 10, and location 10 will always uniquely correspond to a specific public key. And let's say location 25 would correspond to another specific user and another specific public key. So it means that whenever an operation happens where location 10 in the tree and location 25 in the tree is doing a transaction, I know that something is going on between two, two public keys, right? I may not know what the actual public key is, and I do not know the balance or the transfer amounts, but I do know that something has happened between index 10, location 10 and location 25. So this gives a problem that in the future, if person, the public key at location 25 somehow accidentally leak his public key information, and you can go back and look at the history and deduce all the other locations, that he has interacted with. So in that sense, there is that partial leak of information purely from just the tree index, right? So this was something as I was really discussing with the mentors and ideating and looking at the whole idea, we realized that so this approach is not going to work, right? Because in order for the tree to be fully reconstructible from public data, the leaf index gives too much information. So so even though UTXOs are great, they have collision resistance, but we can't really use hashing as a mechanism, for this. So the nonce, in this previous situation, right? The nonce help us to protect ourselves against what is known like a known plain text attack, right? So that you can't deduce the balance, but the problem is with the index, right? So the solution, and when I look back at how Zcash was designed, right? So they have and in fact this is quite similar in almost all other token structures that use UTXOs, is that they have UTXOs like a kind of sequential, right? So the idea is that the UTXOs are added sequentially, they are never removed from the tree, right? And then because they're added sequentially, so there's no way for you to know who exactly was the one who inserted it. And then more importantly, right, you do not know which UTXOs was spent. So the structural UTXO, in the new configuration is that it has a public key, it has an amount, for this UTXO itself, and it has a nonce, right? And the nonce is there just to kind of, make sure that, you can't easily guess, the UTXO. But then how do you prove that the UTXO is spent, anonymously, right? So for this to work, right, how can we actually have a system that, we can prove that the UTXO is actually spent or is unspent? So we need to have some kind of cryptographic, function, algorithm, and it needs to be uniquely linked to each UTXO. That's important, right? So that for every UTXO, there's one unique index map, or binary map, that says which one is used and unused. It also needs to be private in a way that only the spender is able to spend it. And finally, since we are Mina, it also needs to be provable, right? So hash is not going to do it because the UTXOs data is public. So if you just use the hash of the UTXO data itself, then anyone is able to actually figure out that relationship, right? So it's not exactly private, right? And it's also not only spendable by the specific address. So that's where nullifiers come in. So it is a cryptographic construct, right? It has some similarities to a hash in a way that the output of the nullifier is somewhat seemingly random, very much like how a hash function works, and it's a one-way function as well, like a hash. However, there's an additional requirement that the private key is used to compute the nullifier itself, right? And with the public key, you will be able to verify the nullifier, right? You cannot create the nullifier with the public key. It has to be calculated with the private key, but it can be verified with the public key. So this is the kind of properties that we use in a nullifier in order to achieve what we need to do. So, this was kind of, and where I started, I was asking, different Discord channels, the Mina Discord channel, a couple of people, and they all pointed me to documentation. And wow, when I look at documentation, so the thing that shocked me is that it doesn't explain what a nullifier is. So I went to look at the RFC and the paper as well, so it's a very, very long RFC, kind of gets I think pull request, pull request discussion about what a nullifier is, why it's needed in Mina, and so on. I read through the paper as well, trying to understand, what it's actually doing. Because nullifier is not a very well-known cryptographic construct that's used, very often, right? Unlike encryption, decryption, hashing, those are things that it's very well understood. So basically here it says that nullifiers are used as a public commitment to a specific anonymous account to forbid actions like double spending or allow consistent identity between anonymous actions. So not exactly, too easy to understand what it is, but anyway, I went through a lot of these materials. So I will try to now put it in a very simple terms what it actually does. Nullifiers as something that can be used only once. Yes, kind of true. Yes and no. The actual nullifier algorithm itself doesn't guarantee that it can be used only once, but I will explain later on how you can achieve that, right? So basically, the nullifier is kind of like, it is, a typical cryptographic algorithm, but it takes in two inputs, right? It takes in both a normal input, like we normally have in a hash, but it also needs the private key of the user. So if these two inputs combine, you generate the output, the nullifier itself, right? And if you have this input and the public key, then you can verify that this output of the nullifier is correct, right? So what typically happens is that the top part is generated by the user, you submit its outputs, and the verification happens, in the CK app program. So this is generally how the nullifier is using, right? So there are examples in the O1JS codes. You can use it for anonymous. So in this example, it is a use case of how you can do an anonymous claim, of token balances, right? It uses a fixed input X, and then the claimant is able to generate a nullifier to prove that he is someone who is authorized to claim something, right? And also proves how many times or whether he has claimed it before or not. So the way nullifier ensures that it's used only once is a combination of nullifiers and a Merkle map, right? A Merkle map, in this case, is basically nothing other than a Merkle tree with a tree size that is as big as the field size itself, right? Which is basically 256 bits, if I'm not wrong. Yeah. So by combining the nullifiers with a Merkle map and setting a specific index of the map to 1, right, that allows us to kind of basically achieve the effect of having a one-way function and ensuring that something can only be used once and only once. Yeah. So how the nullifier is used, in the case of the privacy token is that, so we have a Merkle tree, right? So here we have the hash, the UTXOs and hash and so on. And what we do is that we take the public key and also we take, well, in fact, yeah, we take the public key and we take the index and we hash it together and we use this, we actually put this through the nullifier function and then we calculate the index, right? And we set that specific index of the Merkle map to 1, right? And this indicates that this specific UTXO has been spent. So in the future, right, if you go back to this function here, what this enables us to do is a couple of things, right? As I mentioned that we want to make sure that the nullifier is only, or the UTXO is only spendable by the owner or by the spender. So the private key ensures that because nobody else is able to, spend the UTXO for that specific UTXO, right? Unless he has a corresponding private key, right? So anybody else, right, is only able to verify with the public key. And in the contract, and since, as I mentioned before, nullifiers has a unique mapping, right, from these inputs to the outputs. So it also makes sure that this specific UTXO is mapped to one specific location, right, within the entire Merkle map, and that mapping is unique. So it means that once you have spent this UTXO, there will be one of the leaf nodes here that is set to 1, right, and it cannot be spent again. So if the same spender comes back and tries to spend the same UTXO again, and in the verification function, you verify that this is 0 rather than 1, and and with that, you can prove that UTXO is either spent before or is unspent. Yeah. Yeah. So this kind of allows us to verify, to basically have all of these properties, right, and make sure that it can only be used once and it can only be used by the spender. Yeah. So when I was modifying the private tree, basically adding a UTXO is relatively simple. You create a UTXO that is basically a hash of the public key, the amount of UTXO and the nonce, right? It's a tuple, and then it's just added, to the next free location within. So sequentially, it's added sequentially within, this Merkle tree. Whereas when you span it, right, you calculate the nullifier, right? That is, did I write this wrongly? I think it should be a nullifier of the public key and the UTXO index, and then hashing it together. What's that? Let me think if I wrote this formula a bit wrongly. But anyway, I think this one is correct, where you calculate the nullifier based on the public key and the UTXO index, right, which gives you this specific location. So, so you will verify, or the smart contract will verify that the leaf node at that specific location J is 0. And then if it's only 0, you will set it to 1. And this action basically spans, a UTXO, right? Oops, sorry. Okay. And since the nullifier function is deterministic and requires a private key, right? So this relationship between the public key to J, to this J index location is both somewhat hidden, right? And also protects the privacy of the user spending. You might need the message as well. Yes. I think the reason why I used I think there was a reason why I used just the public key. So I think I chose the combination of public key and index, this index of this location I. So there's kind of specific to it. Yeah, but so I think basically both methods, would more, I think both methods would have work. Yeah, brand directly is a very powerful construct. Yeah. Okay, so yeah, so some of the applications of how you can use nullifiers, right, is, if you want to do some kind of anonymous voting, so, you could also use a similar structure where you calculate a nullifier, and then have set, a Merkle map, to 1 for every vote, of every voter that has voted, right? Similar, structure can be done for token mixers, any kind of anonymous deposit and claim system, even a loyalty and reward program, right? Where you want to actually have, be able to give rewards and allow people to claim rewards or loyalty, program in an anonymous way, right? So yeah, so I guess this is a kind of a really quick run through, of some of the things that I've come to learn about nullifiers itself. And I think, yeah, if you look at the O1JS code as well, they do have an example. It took me quite a while to understand what this example is actually trying to do. So in very, very simple terms, this is a contract where it actually allows a specific user, right, to be able to claim the rewards, and then ensure that once the reward has been claimed, yeah, the specific user will not be able to claim the reward again, right? So yeah, without actually revealing the identity of the person who was claiming the rewards. So this works. This specific example works, I think, only for one claimant, but it can, obviously be expanded, to do a lot of other things. Yeah. Some interesting things to note as well, like to really understand the codes. You can see here, like in the code for the actual nullifier class, right? When you actually do the set use, it actually computes the witness, it computes the location where it is, and it actually kind of, tries to set that specific leaf node to 1 in a Merkle map, right? And when you try to assert that a specific nullifier is, unused, right, you'll be checking that that location is 0. So obviously, actually, there are more interesting things that you can do, right? It doesn't even have to be binary. So in this kind of setup, you are kind of like, it's kind of working like a semaphore, right? When you set something to either 0 or 1 to be used or unused. But obviously, you can even extend it, to do counters, right? By extending the codes, yeah, and other things. So you can see that the way that the key or that specific index that's being used for a nullifier, is taking the hash, right, of the content of the nullifier here, right? And in my own code, so I actually changed the way the nullifier key is being calculated, because I needed to have a combination of both, right, information coming from nullifier itself, right, and an additional field that represents the index, right? Yeah. So yeah, so with that, actually, so I kind of have a modified way of calculating the nullifier key based on the nullifier output itself, together with the index. Yeah. Great. So these are, just, some tips and examples, and I think some learning points, from this entire journey of, understanding about nullifiers. Yeah. So I think we have, time left, and I hope this session was helpful for everybody. So yeah, so yeah, I mean, I think I want to open, the ground to everybody who, has some questions, or you want to kind of understand, or there are areas that you did not understand about, how it's being used. Yeah, sure, Daniel. Yeah, go ahead.
Daniel, yeah, we can hear you. Or are you there?
Sorry,
I
what?
guess yeah. Let's continue with I am dev because we cannot hear Daniel.
Right. Thank you very much. It was really great talk, and really very clear that you had. But I would like to say to add on to your talk, if possible.
Yeah, sure. Go ahead.
So I created CK Nullifier on MetaMask Snap. So which means that it makes for developer more secure, also for the user, that you don't actually really share your private key. So if you don't mind, can I share my screen?
Oh yeah, sure.
Thank you. So can you guys see my screen?
Not yet. Okay.
So if you look to the example of nullifier, normally if you, for example, if you want to do a transaction, for example, in this case, to pay out the money, you need to have your JSON nullifier to your function, right?
Yeah.
So basically, what you are doing is like that you are generating your nullifier based on your private key and on your message. So
Yes.
the problem here is that you don't want that CK app. You don't want to share your private key with your CK app as user actually. So that's why that is one of the reasons that I created CK nullifier for CK Snap. So this is my project of Mina CK app snap. Sorry. So what I have done is, can you guys see my screen? Okay, it's also clear to see.
Yeah.
Yes, we see.
So a developer can call this function, which is an MetaMask function. And for now, I just have a fixed message, right? Like begin message. But you can in the future, I will be able to you will be able to add a message to MetaMask, and then I create here a private key, a nullifier, and return it back to the user. So let me show you the demo. This is the MetaMask that I asked Mina account here. I do ask a private key, but I don't share the private key to the UI. So the private key stays on the MetaMask itself. As you can see, this is the public key. And you can, as a developer, you can call the snap function. So which means that the nullifier, as you can see, will be generated. So instead of sending private key to the UI, I only send the public nullifier to the ZK app actually. So which means it's more safer to use. So basically, that's the beautiful of this solution, I think.
Yeah, nice. Yeah. I think in the I mean, for the privacy coin that I developed as well, basically also the nullifier function or the nullifier calculation is done not in the contract as well. It's done off chain basically. Yeah, I mean, I'm not very good with UI, so I was building the browser extension, but it was.
But if you do it on the UI, you need somehow a private key to generate it, right?
Yes. Yeah. So
that's the problem.
generating, yeah, not in the UI. I mean, definitely not generating inside the ZK app, but also generating.
So my solution is that you can generate. You can just ask user to sign actually, to generate a nullifier to verify if it's user, if it's he is who he is, So
definitely, I think the next generation of Mina's MetaMask of sorts, would definitely need this kind of functionality. Yeah.
So what I would like to do is I would like to add all this kind of function to all the wallets that Mina has. So like to Pallet wallet, MetaMask wallet, so like any wallets that would be great, That make the life of user more secure, and also for developer it's also more easy. Just call the function, then you get it,
Yeah. So I saw that Pavel asked a question as well. He said that I'm not sure by what level do developers have to directly operate with nullifiers or Mina. So I would say I think no, Laurie's answer is quite good, right? I think it's not. I wouldn't say nullifiers is. I mean, it is a very low level function, but it's there are not any other constructs at the moment that actually wraps what the nullifier can do. It's not like you can use some higher level functions or libraries or other constructs that can imitate what the nullifier can do, because it is a very different kind. It is a completely different kind of cryptographic algorithm, right? And it's a very obscure one, a very niche one, I would say as well, right? I think even among people who are very familiar with different kinds of crypto algorithms, it's not something that everybody is using regularly. So it is for a very specific use case, right? And generally in the case where you have a pool of many things, and you want to make sure that someone has taken something, used something, right, without revealing who that person is, right? So you can think like the examples I given: anonymous voting, anonymous claim, UTXOs kind of examples. These are very good fit for using nullifiers on Mina in general, right? I hope that helps to answer your question. Yeah, so I think otherwise I don't have much else to share. So I hope this session was helpful for everybody. I think it was a very exciting exercise for me, to really kind of dive into this field. ZK is kind of always a bit challenging, on maths and crypto, and these algorithms are not the easiest. So I hope that this can help other people on their privacy journey or ZK journey. Great. Does anyone has any other questions? Yeah.
I just want to say thanks a lot, Shinki. I think this is really helpful for the community, not just about Mina, we're like really into ZK and like interested in nullifiers. So also we'll share it later, and like more people will have use of it. Again, like we are always open to community hosted events. So if you have topics, again, like Shinki or another person, so we are like really welcoming you guys just to host these kind of topic focused sessions. So you can always reach out to me on Discord. Again, thanks a ton, Shinki, for the session and explaining.
Yeah, no problem. My pleasure. Yeah. Great. Okay. Then I think that's all I have. I hope everyone, had a good time and learned something today. Yeah, and have a good day, afternoon, evening. Okay.
You too. Bye bye.
Okay. Bye.
Bye. Thanks.